All right. Now that we've looked at ignition, let's look briefly at structureware. So much like that, we go to data centers facilities and head to Raleigh. Raleigh. Here's our structureware link. This is very much for reference only. We will have graphics and a front end interface just like Ignition, but for the time being, you will need to check this from time to time. This is all the data from the chiller plant. So I'm actually going to open my email in a separate screen so I can get some additional information that I just thought of. Doesn't look like I can. Alright, so just like Ignition, the username and password is raw and raw ops. Alright, here we are. Now would be a good time to preface that you probably should go look at the old Jace controller where we had that old Siemens controller. The BMS cabinet where we have all the VFDs. For the people who aren't familiar with the old J system, it's the cabinet, the gray cabinet in the back hallway that has the 4 VFD screens mounted into it. You open that up and you can see all our I/O buses and all of the relevant information for our BMS system, specifically on the control side for the chiller plant. So, as we talked about briefly, the difference between monitoring and control software. This is the software that actually control the chiller plant, the pump speeds, bypass valves, what the chiller should do, how they stage, given certain failures, how they share load, things of that sort. And we call that a sequence of operations. How does it operate? So to look at this, all of our I/O buses are physically those square boxes that are mounted on the DIN rail in that cabinet. So we have chiller A, M1, M2, chiller B, M1, M2. Each of the chillers, there's 4 chillers and there's 2 controllers per chiller. So there's a digital output for start-stop signals and things like that, and then there's analog signal ins and outs. That's M2. That's handling bypass valve positions, isolation valve positions, things of that sort. So jumping in, we'll just get right into it. Here we can see if the chiller is an alarm. We're getting hardware points from that saying the chiller, if it's an alarm, this will be on, and you'll also get emails. It will show up here. Whether the chiller is enabled or not, we're in hand right now. We're in a very much a manual mode, so that's always going to be off. There's no sensors hooked up to this, so you're not getting that. Really on the screen, all you care right now is flow. So if chiller 1 is supposed to be running and it has, virtually no flow, that's a problem. And we need to diagnose that. So the only thing that it could be is our pumps running, is the isolation valve, control valve open, and is the supply valve open. Those 3 things would prevent a chiller from flowing water. And M2 is kind of a more important one. So like right now, the bypass valve is in hand at 26%. That's fine. That's where we want it right now. It's kind of out of scope. But the isolation valves we actually do care about. So this isolation valve is at 0%, meaning that valve is physically closed. I'll actually just show you what these valves look like. The LEMO control valve. So they are one of the bigger Belimo control valves. Let's see if we can see it. Very similar to this one, but more in line. I want to find one with the manual crank on it, just like the one we have. That's super important. What is that, a 14-inch? Interesting. I can't find the one that we have. So if you go up into the chillers, up onto the roof, or here it is. If you go up onto the roof and look at the chillers, there's this box on the return side of the chiller, and that's what we're calling a control valve. So these indicators indicate the position of the butterfly valve. So in this position, if it's 90 degrees perpendicular to the pipe, that means it's closed, and it'll actually say 0 degrees here, or 0%. It'll say 0 right here, and this is 90%. So 90 being fully open, so it would be in line with the pipe, and that's what this would indicate. So at 26%, this is going to be roughly in this area and only letting a certain amount of water go past, which for the bypass valve, that's perfect. The isolation valves, we either want that at 0 or 100. We're really never going to run that in between for now. Maybe we'll do it for some freeze protection where we'll crack it 10% if it's below 32 degrees outside. Right now, we don't have any plans for that. It's not a thing right now. So real quick, we can just check. What's chiller A doing? Okay, its isolation valve is shut. Okay, it's not running. It can't run. Chiller B, its isolation valve. Oh, I clicked M1. M2. Chiller B, M2. Its isolation valve position. It's forced at 100. And there's my feedback. It's at 99%. We know that chiller's running. So when we go back to M1, we know there should be flow here. Exactly. So we have 900 GPM of flow. So we know that chiller's running. What's chiller 3 doing? Chiller C doing? Let's check M2. The ISO valve is open at 99%. Therefore, we know that chiller C should have flow. And it does. Almost 1,000 GPM. And chiller D. So what state is it in? We know that the feedback valve is actually at 50%. That's kind of alarming. I had just said, hey, we don't want anything to be at. I don't know if that's a, and there it is. It's a requested value. For whatever reason, that was told to be in that position. And there we go. Chiller D is now showing no flow. That's perfect. That's exactly what we want. And we know that the isolation valve is at 0 now. That's fantastic. That's perfect. So we know we have 2 chillers running. So that's an overview of this. This is very temporary until we can get our graphical interface and port it over into Ignition. But it is important for you to know now that you can log in this, so you can log in and see the status of the chiller. So if you want to view the chillers itself and view all the data just like you're using the screens mounted in the back hallway, we go to the BACnet interface, because that's the protocol that those chillers communicate with. So very much like internet or TCP IP, the chillers use BACnet. It's just a different protocol, same wiring. It's literally BACnet over TCP IP. So we look at that, we go to IP network since it's internet protocol based, and we can look at chiller A application, and we have all the information. We know chiller A is set to cool. Its capacity is at 0, meaning it is not running, which we already confirmed with the isolation valve. It's not an alarm. What else is discharge temperature? 52 degrees. We know that's not true because there's no water flowing through A here. What else do we get out of this chiller? Leaving evaporator water temperature, so that's going to be your leaving temperature. That should be at 46 at set point. We can actually see the set point here as well. 46 degrees Fahrenheit. And that's it. So we can view all of the chillers through this application right now. It will be much more streamlined in the future. I have to. Oh, here we go. Here's one of the running chillers. We know it's running at 43.8. If you go back to the chiller screen and look, you will absolutely see it saying 43.8. Whether it's 0.8 or not, it's close enough. Compressor, and we know it's cooling. Yeah, big deal. Compressor hours. Compressor starts at so many times it's started. A lot of not useful information. Basically, you care if the chiller's on and what its leaving water temperature is. So we know the target is 46. That's a set point. What's its leaving water temperature right now? We know it is, that's entering water. So that's not it. We know its leaving water temperature is 46 degrees. That is exactly the set point that it's supposed to be. So those are the two things that we care. Does it have flow? Its entering water temperature and its leaving water temperature is what we care about. That was chiller B. Same thing with C. We know C is running because we already verified. It is cooling. Its active target is 46 degrees Fahrenheit. What is it cooling to? It's cooling to leaving condenser water temperature. Evaporator leaving water temperature. Boom, 46 degrees. Perfect. And its entering water temperature is 50 degrees. So 46, 47, 48, 49, 50, 51. You know we're getting 5 degrees delta T. So the water is leaving at 46, coming back at 51. So we're getting 6 degrees of temperature rise. 5 degrees of temperature rise, which this system is designed for only 6. So we're almost hitting the perfect design load now with all the pumping and changes that we made. So it's almost running perfect. So again, cautioning you on using this site because you actually can change data. You can change accidentally change things. The good thing is it's not going to let you change anything without saving it. So unless you hit save on something you've changed, it's not going to commit that to its memory. So we could tell it we want to change this value of this pipe. So I could change the state of the data center right now on this bypass valve by typing in something, hitting force and save. But again, it's not going to let you do that, provided that you don't save. So this is something you can look at in the interim until we get graphical interfaces. Feel free to poke around, be very careful. You really only care about I/O bus and BACnet interfaces. The only two things you really should be in or care to be in to view the status of each individual chiller as well as the I/O bus. So really briefly going over this again, we log in I/O bus. These are the boards that are in the closet or in the cabinet. Chiller A is the digital point, so this is coming right off the chiller. We care about really only flow on this page. We want to know if the chiller is flowing water. So there was no flow. On chiller B, we have flow. We know it's running. And then on C, we have flow. We know it's running right here. And what's D doing? Oops. D has no flow. It's never going to flow 1.43 gallons. It's going to flow hundreds of gallons at a minimum. So we know B and C are our active units. So I just know, because those are our active units, what's our isolation valve feedback. It's going to be almost 100 on B and C. And we just verified that that is, in fact, true. And then briefly, we want to go back to BACnet interface, IP network, and we can verify A is not running because its unit capacity is going to be 0. Chiller capacity, 0. It is not running. B is going to be roughly in the 40s. 40% range. Where are we at? How did I miss it? Right here. 41.4. And we know C is running real quick. We'll go here and see that it's running at 44.4%. And chiller D, we've already verified, is off. So we're going to see it's a 0.0. Where is it? Not that far down. Chiller capacity, 0%. So, again, any questions, feedback is also welcomed. Send me an email or IM or anything if you need something. But again, in summary, this is how you look at the chiller plant right now while it's in our manual mode. And be careful. You can change things. It will not let you accidentally do that, so feel free to poke around. Again, that's IO bus and BACnet interface is the only two things that we care about. M1 is our digital inputs. All we care about is flow, and any of the M2s is isolation valve. So those three things. We want to verify again that flow is happening and the status of the valves. The ISO valve is what's dictating a chiller is running or not. The isolation valve is closed, it will not run. If it is open, it will run. Those are the criteria. Very, 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 very simple.